Festival of Britain, 1951. The Skylon, symbol of the festival, this name, already passed into household use, was coined to describe the graceful structure reaching 290 feet into the skies, which has captured the imagination of festival visitors from every part of the world. The architectural aim was to provide a simple, dominant, vertical feature soaring upwards in direct contrast to the complex and horizontal character of the exhibition lying beneath it. The Skylon was built by British Insulated Calendars Construction Company Limited to the competition design of architects Powell and Moyer, the specification of the consultant, Mr. F.J. Samueli, and under the general supervision of Mr. Ralph Freeman of Freeman, Fox and Partners, the engineering consultants for the festival works. Its manufacture and erection called forth all the resourcefulness and ingenuity of staff well experienced in solving the many problems involved. The order for the Skylon was received in September 1950, and despite the fact that barely 6 months were left in which to finalize the design, to prepare detailed drawings, and to manufacture the parts, the work was completed in time for the official opening of the festival by His Majesty the King on May the 3rd, 1951. Viewed from a distance, or from across the river, the feature, shining in the sun by day, illuminated from inside by night, does by its very shape act as a pointer to the exhibition. Taking the scene, the Skylon stands poised, proclaiming the proud spirit of the people of Britain. The feature, a tall, thin, pointed body, is suspended 40 feet above exhibition crowds on the large paved area below, a heavier-than-air structure in a cradle of steel cables supported on 3 legs which contrive to be inconspicuous from the surrounding buildings. A deliberate illusion is therefore created of a graceful and unusual structure divorced from the earth, achieved by the application of simple and practical principles. The site chosen was next to the Dome of Discovery and other exhibition buildings already in course of construction by contractors who were also working against time and the additional handicap of long spells of wet weather which characterized those hectic months. Gradually, these obstacles were overcome, and the millions of Londoners who daily passed on their various ways witnessed a magical transformation in the heart of London. Where ruin and decay had for years remained an eyesore, a new panorama grew out of the dust to become the most exciting architectural adventure of modern times. On the site, which is close to the river wall, work on the foundations proceeds until the excavations are 15 feet deep at the 3 main points. These foundations and anchorages, which can be seen complete in this plan diagram, are combined in a single reinforced concrete construction. 3 arms, set 120 degrees apart, radiate from a central hub. Each arm, at its end, enlarges into a single heavy block of reinforced concrete, in which the anchorages for the windstays and supporting cradle ropes are set. The point of each anchor is set at a distance of 64 feet from the center of the foundation. At a position 16 feet along each arm, a concrete block is built to support one of the 3 steel legs, which in turn support the steel wire cradle on which the central feature rests. The outer and inner blocks and the hub are all connected by a concrete raft to make one solid foundation unit. This perspective diagram gives a clearer picture of the steelwork construction at the base of one of the cable anchorages. Each anchor holds 3 wire ropes, 2 cradle-supporting wires, and 1 central windstay, all 3 held in position by a single steel pin. The great depth and width of these foundations gives some idea of the size of the steel sections which are to be lowered and bolted into the complete assembly within the foundations. The excavations for the base anchors have been got out at the 3 points of an equilateral triangle, each 64 feet from the central point over which the Skylon will be suspended. The temporary stay positions and main anchor are encased in reinforcing rods and shuttering. At this stage, the head of each anchor is left clear of the concrete, which now encloses the heavy girder construction. When the 3 anchorages have been completely concreted, all the excavations are backfilled. In the case of the anchor adjacent to the river wall, the pressure of water at high tide had to be taken into account. The ground is immediately consolidated with a pneumatic punner after each load is restored. As the dark days of winter pass, the abnormally wet weather gradually gives way to improved conditions. Throughout the exhibition site, building activity of every kind proceeds with renewed energy. Time lost through bad weather has to be made up if all is to be ready on time. Meanwhile, the 3 legs of the Skylon have arrived on site after their long journey by road from Messrs. Painter Brothers of Hereford. These steel legs, 70 feet in length and weighing 6 tons, were prefabricated and delivered to the site in one piece. The trailer is driven through the exhibition grounds and on to the Skylon position, where a temporary falsework structure of steel angle sections has already been built to support the feature during the early stages of its construction. The legs are maneuvered into position and unloaded from the trailer to their appropriate position. By means of 2 derricks straddling the member at its far end, it is hand-winched into its approximate position. With the first leg raised to an intermediate point, the hoisting is continued from the falsework, while the leg hinges on its massive pin. When the leg has reached its correct initial position, the derrick tackle is disengaged to enable the operation to be repeated on the remaining legs. All 3 legs are, for the time being, guyed off to the falsework in an upright position. Two of them are then luffed in to lift the bottom section of the feature onto its temporary resting place at the head of the falsework. This section, which is 32 feet high, is welded to a steel spider and registered on a 2-inch hardened steel ball, providing the 3 points of attachment for the cradle or supporting cables. Extreme care is taken to ensure that this first section is held truly vertical before further sections are added. With the base in position, the 3 legs are moved back to their approximate final position to enable further construction to proceed. To hoist further sections, a central derrick is now rigged inside the feature, which is a 12-sided structure built of rectangular frame. The sections are hoisted and loose bolted into position before being tightened up to adjacent sections. Great accuracy was essential in the fabrication of the panels and in the centering of the bolt holes, to ensure that the material would fit together correctly in course of erection. Construction of the central feature having reached the mid-height position, the 3 permanent wind stays are now fixed. They are attached to plates forming part of an internal braced frame made up in 3 welded sections and bolted together in position. Each stay then passes through the sheave at the top of the corresponding leg to its ground anchorage. At each anchorage, the ends of one of the wind stays and 2 adjoining cradle ropes are pulled in by means of special landing gear to be attached by a single pin to the anchor steelwork. All supporting cables are pre-stressed ropes of spiral construction and are composed of stranded galvanized steel wire. They have a circumference of 7 1/4 inches and were specially made at the works of Wright's Ropes Limited. The 3 rope couplings shown here at one of the anchors have now to be led into position. These heavy cast steel couplings are designed to fit over the 3 plates in the anchor. The steel pin, which is a dead fit, is now removed, and a wire pulling strap placed round the couplings, which are levered in until all holes are in alignment. A liberal coating of grease is applied to the anchor pin before insertion, and a final inspection made by an engineer. The supporting wire ropes are tensioned by upward and outward movement of the legs. These in turn are moved by the 100-ton hydraulic jacks, one of which is fitted at the base of each leg. Careful measurements are taken along the stays from the spider to the head of each leg before clamping it into position. With the stays correctly braced, the feature is now just clear of the temporary false work. Strain gauges are clamped to the cables to check the tension. The supporting cable is running from the anchor over the sheaves at the head of the leg, down to the steel spider, and then over to the adjoining leg, and down again to the corresponding anchor. At the same time, each windstay runs from its attachment on the feature and is registered by the sheave at the top of the respective legs and continues to an anchorage. The cables are now taking the strain of the feature, and erection of the upper structure proceeds. To facilitate work in the air, 4 sections are bolted together on the ground. At intervals throughout this framework, plates are fitted to which cross-bracing members will be attached. A coat of protective paint is given to the bolted assembly. Sight welding was necessary for a few connections where bolting would have been difficult. When the assembled sections are ready, they are hoisted by means of a power winch. To avoid damage on its journey up to the erectors, a tail rope is attached to the traveling section to keep it free in mid-air. A foreman, coordinating winch and erectors, sees the assembly safely to its destination, where it is landed and bolted into position. Already, the structure is 3/4 high, a landmark to the busy Londoner across the river. The summit of the Skylon is a 19-foot cone, supplied in one piece. At its extreme end, a circular plate is fixed on which an anemometer will be bolted for measuring wind velocity. Fixing the cone in position presents a problem which is overcome by the use of a single derrick and special tackle. From their lofty point of vantage, the erectors can survey the general activity all around them. By now, the Skylon has captured the imagination of the British public. The BBC, taking advantage of the unique opportunity which presents itself, sends their well-known commentator, Mr. Winford Vaughan Thomas, on a voyage of discovery, up the side of the structure in the erector's cradle. Listeners all over the world are given a first-hand eyewitness account of the progress in construction of this unique example of British engineering. The exhibition workers declare an unofficial holiday and swarm round the recording van to watch the progress of the cradle. Under the watchful eye of the winch driver, their journey accomplished, the Skylon's visitors are brought safely to the ground, and work is resumed once more. Inside the central feature is fitted a light spiral cat ladder with landings at suitable intervals. This ladder is installed primarily for use by the engineers in maintaining the lighting system. Through the center of the feature runs a 2-inch bore steel tube which supports the internal lighting fittings. The Skylon is illuminated by 500 lamps varying from 60 watts at the bottom to 200 watts at the top. These lamps, with their reflectors, are spaced at regular intervals throughout the length of the steel tube. The total power required for lighting is of the order of 30 kilowatts. Light is thrown onto the louvers by the internal cone reflectors, thereby illuminating the whole feature at night. These louvered reflectors are prefabricated and delivered to the site ready for fitting to the face of the structure. They are made in 6-foot lengths of aluminium sheeting. Sections of louvered cladding are loaded into the cradle and taken up in batches. Approximately 300 of these sections are used to cover the 12-sided surface of the central feature. Accustomed to heights as they are, the steel erectors are faced with a tricky job at the summit of the feature. Nearly 300 feet above the exhibition, the peak is one of the highest points in London. Working in pairs, the fitter on the outside places the panels in position to be bolted on by his opposite number inside. Power spanners are used to facilitate the bolting down of the sheets from the inside. As work proceeds, clockwise and anti-clockwise round the feature, the louvers, carefully dimensioned and numbered, fit into position without a hitch. To avoid damage to the sheeting, the cradle tackle at the top is lowered below the finished work as each 12-foot depth is completed. As work continues down towards the center, the fitters at the base are working up to meet them. The lower half of the feature, falling away from the vertical, is not liable to damage by tackle, and work proceeds in the normal way. At this stage, the fitting is well in hand, the gleaming aluminium completely altering the outer aspect of the Skylon, seen now against the fairer weather skies. With its cladding finally completed, the structure, the Skylon as a whole, is now ready for final adjustments. The jacks fitted at the base of the legs are again brought into play. Fitted into the recess made for them in the reinforced concrete work, they are then enclosed in a brick surround. The enclosure is built up to a height that will correspond to the finished ground level. The jacks apply an upward force to one end of a lever arm, the other end of which is hinged, and the center of which supports the leg. It is essential that the three jacks work closely together, and continual inspection is made to keep the pressures level as the force is increased. The heavy jacks are mounted at an angle. A specially designed head was made to accommodate the underside of the lever arm, which is pivoted on its hinge. Slowly the pressure is built up level at the 3 points until the correct reading is reached. The reading is finally checked at each pump, and jacking ceases at the predetermined figure of 95 tons. At this point, jacks are eased off and a dynamometer inserted to obtain a direct reading at the jack face. The load is then transferred to the rolled steel packing joist and the jack finally released. This operation is carried out at all 3 points, leaving the legs supported by the steel packings. Readings are checked on the strain gauges, now encased in their plastic weatherproof covers. The feature now stands fully braced, well clear of the falsework. The additional ladder is hoisted and the falsework moved over to allow the extreme lower tip to be fitted. This final section, which carries 3 flanges that correspond to the spider at the supporting cable position, is hoisted up and bolted into position, and the whole feature completed. The falsework is now carefully lowered to the ground to be removed, and with this out of the way, the foundations can be filled into ground level and the final dressing of the site completed. Concrete and asphalt now cover the foundations, while the jacks are protected and also made easily accessible with the fitting of a 2-piece inspection cover. A few weeks later, a new monument to British ingenuity stands securely on its foundations, with all traces of its inner strength concealed.